Hello, this is Team 11's design retrospective for Project 55, Machine Learning for Automated Insect Classification. My name is Dave Arnold, and I would like to talk about some of the processes we used in the course of our project, in particular project management and version control, both of which we enjoyed great success with. For project management, we chose to develop using Agile, more specifically the Scrum methodology. Scrum worked out really well for us, especially in the beginning. We were experiencing some changing requirements. We were experiencing some requirements being added to the project. So Scrum allowed us to maintain some flexibility to respond to those changes. For our Scrum board, we used Taiga. Taiga was nice. It allowed us to track our progress, track our teammates' progress, and offer some transparency to the team and to the sponsors. We had 9 sprints in total and over 250 individual tasks that were completed. For version control, we chose GitHub. We had 7 repositories in all. We had repositories for the web app, the servers, the API, both web scrapers, machine learning model, and the Android application. It was part of our plan all along to have this many repositories. We wanted to stay true to the idea of separation of concerns. We wanted to each be able to develop the component we were responsible for and not have to rely on what somebody else may have been doing or rely on any particular framework somebody else may have been using. And it worked out really well for us. Everything came together in the end smoothly. We were able to piece everything together, and it turned out really nice. If there's something we could have done to improve the process, it would have been to utilize the features of Taiga more specifically adding points to the user stories to better track our velocity. We had a pretty good idea all along where we're at in the development of our project, but utilizing Taiga's features would have gave us a more accurate idea.
My name is Sadai, and I'm going to give an overview of the design and architecture of the system we delivered. On the right-hand side, you can see a diagram representing the complete system. The biggest change we made to this diagram since the last time we went over it is the removal of the API gateway component. The reason we went with that change is that we were informed that the end classification application would only be available within the ASU private network, and an API gateway would have introduced more complexity without matching benefits. Instead, we focused our efforts on 1, adding authentication support to the web application, and 2, reducing security risks by making all APIs internal. Our web application then just acts as an authenticated proxy to the classification API. The authentication functionality was implemented via Auth0, which is a free identity service that provides some really nice features out of the box, like allowing users to sign in to our application using their Google accounts, like the Gmail accounts provided by ASU. So now let's shift our focus to things that worked well for us. One of the keys to the successful completion of a project was leveraging the idea of separation of concerns to our advantage. It allowed members of our team to work independently, and it also made it really easy to keep tasks and code organized into loosely coupled blocks of functionality. This made both our process and software artifacts highly scalable. The different components of our application can be deployed as independent clusters that can scale horizontally without code changes. Our use of Docker makes it really easy to accomplish this by using something like Swarm or Kubernetes. Another thing that worked really well for us was choosing Docker as our deployment mechanism for the different microservices we worked on. Everyone used a different development environment to work on their components, like different operating systems, languages, and tools. But we're all able to easily test the entire system as well as the individual components in our boxes thanks to Docker. We were then able to use the same images to deploy the entire system to production without any changes. All the components were configurable by settings found in configuration files. Finally, as far as things that can be improved, the entire CI/CD pipeline would benefit from automated testing. All our testing was done manually, which doesn't scale very well in the long run. And then the web app would also benefit from the whole principle of single-page apps, as it would improve overall responsiveness and would also make it possible to replace the web server component of our system with calls to our internal API.
My name is Larry Pruitt, and these are the tools our team used. Slack was by far the most utilized tool. It was an excellent way for us to communicate, to send files back and forth to each other, and communicate with the sponsors. We could have been a little more organized. We ended up with many channels, and it was a little difficult to find things at times. The Spectre machine is another tool we use. It was excellent for training models, has 4 GPUs. Huge problem was it was frequently unavailable, and the first one actually crashed. We had to switch to a second one. An improvement would be that we go through the Spectre machine administrator directly as opposed to going through our project sponsors. Keras is another tool we use. It's basically a wrapper for TensorFlow. We discovered Keras about a month into the project, but didn't start using it till the second month. An improvement would have been going directly to Keras as soon as we learned about it, as opposed to pursuing TensorFlow. Beautiful Soup is a tool that we use to scrape the bug guide dataset, as it doesn't have an API like AntWeb does. Originally, we planned on using Scrappy. However, we discovered Scrappy did not provide the tools necessary to scrape the bug guide dataset efficiently. Travis CI is a continuous integration tool which helped us monitor pull and merge requests. It also automated the building of Docker images each time source code was updated. TensorBoard is a tool that we never planned on using. However, we ran into some issues training the model and we wanted to see what was going on. So we leveraged it to plot training in real time, plot images of ants, and to plot the confusion matrix at the end. On the right are 2 of the confusion matrix plots.
Hi, my name's Aaron Halsman. I'll be presenting on teamwork for our project. Let's talk about things that worked well first. Communication was probably one of the best, one of the major keys to our success. Over here you can see our Slack channel, of course. There's our conversations going on, and these are the many different subject topics that we had. Kind of organizing our conversations into different topics. We had one for the machine learning model, another one for data sets, another one for the Spectrum machine early on when we were learning how to use that. Anyways, it helped that all of us were so available to talk about different things, and that definitely helped with our project. Another thing that worked well was the division of tasks. It helped keep everything organized early on. We decided that each person would work on a different component of the project, and early on this was definitely helpful in keeping it organized, but later it definitely turned into more of a hindrance, but I'll talk about that more in a second. Another thing that worked well for us was the meeting participation. We had weekly meetings with our sponsors, and most of the time everyone was actually able to show up and participate a little bit, and that definitely helped keep everyone up to date with what was going on in the project. So that was cool. The thing that we could have improved on probably, though, was actually our division of tasks. Towards the end of the project, we kind of got bottlenecked where nobody could make any progress until another person finished their component and we were able to start collaborating. So probably having everyone work on the same component at the same time might have helped in that respect. So anyways, thanks for listening.